We're going to be talking about the Theorem of Thales, and all we need to have for this theorem to apply is a triangle where these 2 points are the diameter of the circle, so they pass through the center of the circle, and we just need a third point C at any point on the circle. So we have this triangle ABC, and this triangle will always be a right triangle. And the reason for this is because if we look at these 3 line segments AO, CO, and BO, they are always they're all congruent to each other because they are the distance from the center to the circle, the endpoints of the circle, aka the radius. And so since we have on both these triangles we have 2 congruent sides, then this is an isosceles triangle, which means that these angles, so on the left triangle we have the angle CAO and angle ACO are both congruent to each other, which we can see, but these are the blue angles, and then similarly we can have the red angles congruent to each other on the right triangle. And because these angles are congruent to each other, then this angle up here, ACB, will be the sum of these 2 angles, the blue and the red, which, as we can see at the bottom, that's a sum of 54.74 degrees and 35.26 degrees, which should be 90 degrees, and we can change this point C to be any point on the triangle, and they will always add up to be 90 degrees.